Okay, how you guys doing tonight? It looks like almost everyone is here. A few more signing in, but let's go ahead and get started. Hope you guys are doing well. Okay, so we're reaching the kind of the midpoint of the term. And so after tonight, we'll have finished up the first portion of the class and bringing us up to the midterm. And so we've done all the new chapters I wanted to do prior to the midterm, which is going to be assigned later tonight. And so you guys have done all your homework, except for the elasticity one, which is due next week with the midterm. Okay, so it looks like almost all of the homework assignments are in. I think there's one more student that needs to turn in the last homework, homework 5. And so once that's in, should be probably today or tomorrow morning, I will post the solutions, or my solutions for the homework, so you guys can look at those if you need that to study for the exam. Okay, so all the homeworks are almost in except for the one. Next week, at the end of today's class, I'm going to assign you the midterm, and then also recall or remember that the elasticity homework is also due next week. And so you got two things due next week. They're both very important. So next Friday, May 1st, the elasticity homework is due, and along with the midterm that I'm going to assign later tonight. Okay, so what we're going to do today, or right now, I guess, unless there's any additional questions or anything else, is we're going to do a little review or study for the midterm exam. And so I prepared a kind of a practice exam with my solutions, and we'll go through that. And then once you guys feel good preparing for the midterm and doing the other homework, the elasticity homework, then at the end of today's WebEx meeting, I'll post the midterm, just a Blackboard, and then that'll be due in a week. Okay, so if there's no more questions, let's go ahead and look at the midterm spring 2020 section. Okay, and so you'll see here that we have a practice midterm, and there's the midterm solutions that we're going to go through, and this will give you a good idea of what to expect for the midterm. what you guys have to do after we finish tonight's session. Okay, so you can open up, or let's just open up the practice center first, I guess. Okay, so your midterm will be very similar to this one. There's going to be kind of 4 big questions, and we'll go through all these. And so there'll be one on the net present value analysis, and there'll be one on the elasticity and regression analysis. So I'm going to give you guys just a little data set, and you have to just do the regression and analyze that. Okay, there'll be one on the budget line analysis that we did kind of as a homework assignment for chapter 4, I think. Okay, and then the last one will be on something from chapter 5, which was finding the profit maximizing usage levels, so labor. And yeah, so there'll be one of each of those 4 types. And so I kind of picked 4 main topics that we've covered in the chapters and the homework assignments that I thought might be the best for the exam. Okay, and so we'll go through these along with my solutions. Any questions on any just general exam questions before we just do the practice midterm? Yes, this meeting is being recorded, and because I know that, yeah, so all the meetings, so I just posted a question. I know that I've had some students in other classes say they couldn't view the WebEx recordings. Have you guys been able to watch or view the WebEx recordings if you attempted? Okay, great. Yeah, because some students have and some students haven't, so I just wanted to make sure. And so if you cannot view the recordings, just let me know. I think you have to have the WebEx on your desktop or just the desktop version to view it, but you should be able to view all the recordings. Yeah, okay, great. Okay, so just in case you didn't see these, you know, if you come to all the meetings, you probably don't need to listen to them again, but just in case you want to double check something or you miss it, I am recording all the meetings starting, I think I started in like week 3, but if you go in the Blackboard where it says WebEx recordings, okay, those are the last 3 full recordings that I'm recording today, and all the other ones in the future that I'll post after we finish. Okay, so let's go through the practice exam. Okay, so the first one that'll be on your midterm will be on the net present value analysis. Okay, here, so we have number one on the practice one is we have a disc jockey that's contemplating the purchase of a new turntable that will cost $1,000 and has a useful life of 5 years. And the turntable will yield these year-end revenues. So at the end of each year, if the DJ buys this turntable, you get $500 in year one, $300 in year two, $100 in years 3, 4, and 5. So these are the payments in the 5-year period, and then after, we're assuming that it only lasts 5 years. Okay, so you have the general formula that you've been using to get your net present value, where you discount all the future payments, and then you have to subtract the cost to see if it's worth the investment. Okay, so part A is what is the net present value of the turntable if the interest rate is 5%. Okay, so you want to plug in your payments or the revenues, the year-end revenues, into each of the periods, year 1, 2, 3, 4, and 5, and then discount it in the appropriate discount rate. Okay, so the first year is $500, and at the end of the year, you're divided by 1 plus the interest rate. So the interest rate is 5%. So in decimal terms, that's 0.05. Okay, so 1 plus 0.05 is 1.05. And then at the end of the first year, it's just the exponent is 1, so it's just 500 divided by 1.05. Okay, in the second year, we get $300. And that's discounted or divided by 1.05 squared. All right, so 1 plus the interest rate, and then period 2. And we get $100 in year 3, and that's 1 divided by 1.05 to the third, for the third year. And fourth year, we get $100, and that's divided by 1.05 to the fourth, for the fourth period. And finally, the fifth year, before the turntable is not used anymore, you get $100 divided by 1.05 to the fifth, and because you had to wait 5 years. Okay, so that is the stream of payments. This is all this stuff here. Okay, and then you also have to subtract the C0, which is the cost. So minus the initial cost of 1,000. So all that, the string of payments that we just added up, and then minus 1,000. Okay, if you put all of this into your calculator, the payments minus the cost, for this one I got negative 4.69. Can you use Excel to calculate it? You can use Excel to calculate it, but put in this formula. So you got to show this part. Okay, so somebody asked, can you use Excel to do this? And so you can use Excel to calculate it instead of a calculator if you want to, just to double check. but you have to show the full formula with the actual numbers, and so you have to show this part. Okay, and so once you show that part, or whatever you're supposed to show for this problem, how you get the correct answer is you can use a calculator or Excel, whatever you want to do. If Excel is easier, that's fine. But show this step, and then it's up to you to get the right calculation. Okay, so I got negative 4.69, which is rounded off just to about a net present value of negative $5. Okay, and then should the DJ purchase the turntable? Okay, and so we added up all the benefits or the stream of payments or the revenue, and that looks like it came up to a little bit less than 1,000 because we subtracted 1,000. And so the answer is no. The DJ should not purchase the turntable because the net present value is negative. Or once you subtract the cost, it wasn't worth it. And so basically what the DJ should do instead is if he or she can earn interest at 5% in some interest-bearing account, then instead of buying this turntable, he or she should just put the money in the bank account and earn 5% interest. So this is the net present value of a project is always an alternative to what you could do in just a banking account to get the interest rate. So the correct answer here would be don't buy the turntable, and instead the DJ should invest that money in a bank that pays an interest rate of 5%. Okay, so net present value analysis. Okay, net present value analysis. Any questions on this problem or what to do for this one? Okay, let's move on to number 2 for practice. Okay, so number 2 is on the elasticity regression analysis. And so this is similar to the elasticity homework in the chapter 3 homework, I believe it was. Okay, so this one says to use this file. And so for your midterm, you're going to get an Excel file to use. And so the file for this one, I posted it on the Blackboard just so you can see it. Okay, so file Q2 is right there. Okay, and so you'll get some natural log data. That's all you get that's all you need to do this analysis. You'll have a natural log of quantity, a natural log of price column, and then a natural log of something else. Okay, and all you have to do is run the data analysis, if you could do that, and run the regression to answer this one for your midterm. And so I've already done this, and I'll show you the results. But since you guys could do the homework for the elasticity homework, I'm assuming you're able to do this. And so everybody can successfully run the regressions, right, in data analysis. Okay, so if you can do it for the elasticity homework, then you should be fine with this. And so, yeah. Okay, and so when you, let me write this here, I guess I didn't specify, but when you turn in your homework, when you turn in your midterm, you don't need to send me your Excel file, just the screen cap of the regression results. So you can send it to me if you want, but I don't really need to see it. So I'll just specify here that. Okay, so you don't need to email me your Excel file with your midterm 2 answer sheet. So this is, I already know what the data looks like, and it's just, the only thing you're going to get besides this is the regression results, and so you just need to put that into your Word document or PDF or whatever you're doing. And so I just need the screen cap of the results. So you're not required to send me your Excel file. Okay, so I did this analysis, and so let me show you. I have the answers in here. Okay, so for question 2, you're going to use the file that you're given, and then it'll say estimate the following regression. For this one, you have to estimate the natural log of quantity as a function of the natural log of price and the natural log of income. And so it should be just the variables you see in the Excel file you're given. So you're just estimating the natural log of quantity as a function of the natural log of price and the natural log of income. Okay, then part A, and part A in your midterm, when you do it, will be just include a screen cap of your regression results or the summary output. So this is all you need Excel-wise for this problem is you need Excel to do it, but you just need to include a screen cap of the results for your analysis. Okay, so I put my Excel file with my answer sheet here, so you can see it if you want to for an example. Okay, and all this stuff, all these resources for the midterm are right here for the midterm spring 2020 section on Blackboard. Okay, so you'll be getting some data like this, and you just have to do the data analysis to get the regression. All right, so you'll get something like that. Which will be similar to what you did for the elasticity homework. And then all you have to do is take a screen cap of this chart or the summary output and put that into your answer sheet. So you don't need to send me this Excel file, just this part. Okay, but if you want to see mine as an example, it's there for you to see. Okay, and so for this one, I did the estimate, and this is what we got. So I normally only do 2 decimals, but I made 4 decimals on this one because the R squared was so high that it would have just been 1, so I didn't extend the decimals, and so I specified 4 decimals, but normally you can just do 2. It kind of depends, but again, the only reason I did 4 decimals is because the R squared would have rounded off to 1, and so I wanted to get a few more decimals in there to make it 99 for example. Alright, so these are your adjusted R squares number, these are your coefficients, and these are your t-statistics. Alright, so part B will be to write out the estimated equation using the estimated coefficient. Okay, so we can see that we're estimating the natural log of quantity as a function of the natural log of price and the natural log of income. So the natural log of quantity is a function of the intercept, which is 1.5096 minus the coefficient for LNP, which is negative 0.1690 times LNP plus the coefficient for LNI, which is 0.0400. Alright, so there's your full equation, which you're probably familiar with doing, and so all you have to do is start with the general equation. That one there, and then plug in your coefficients for the beta. Okay, part 2. Let's interpret the adjusted R square. Alright, and so this one is really high. And so with 4 decimals, the adjusted R squared was 0.09996. Okay, and so very, very close to 1, but in decimal terms, percent terms, that's approximately 99.96% of the variation in LNQ is explained by this log linear regression. Okay, so there's that. Okay, so part D is let's analyze if the coefficients are significant. And okay, so let me specify one more time with the decimals. So okay, so again, I use 4 decimals here, but 2 decimals is fine for your midterm answer sheet. So I know that the one I've already completed your midterm, and I know that 2 decimals will be fine, which makes it a little bit easier. So you're welcome to use 4, but if you want to stick with 2, it might be easier. And so 2 is fine if you want to do that. Alright, so are the coefficients for your explanatory variables statistically significant? Okay, so there's many ways to analyze this, but we're just focusing on looking at the t-stat, which is what we've been doing for our analysis. Okay, so the T-stat for LNP is negative 62.2265. And remember, we're just taking the absolute value and comparing it to 2. This is way bigger than 2, so this is very significant, probably at the 99% level, but 62, etc. is bigger than 2, so this one's significant. Okay, and for the natural log of income, the LNI, the T-stat is 47.5149. Again, very big T-stat, high confidence level for both of these, so much bigger than 2 in absolute value, so both of these are clearly statistically significant. Okay, and part E is to interpret the variables that are significant only. In this case, because they're both significant, you have to interpret them both because they both have a clear explanation of what's going on. Okay, so the coefficient for LNP is negative 0.1690, just from right here. And we have to interpret that. There's 3 things you can say about all these elasticities. So the effect of the natural log of price on the natural log of quantity, we know that's the own price elasticity. Okay, and we know if we do the elasticity test, we take the absolute value of the coefficient, and this one is less than 1. So that means demand responds less than price changes, so it's less responsive than price, which means it's inelastic. Okay, and then the full interpretation is this is the percent effect of price changes on quantity demanded. Okay, so if price increases by 1%, then the coefficient is the effect on demand. So if price increases by 1%, quantity demanded decreases because it's negative by 0.1690%. So very inelastic. Okay, and the other one is the natural log of income. The coefficient for that is 0.0400. Okay, so we know that this variable, when you have the relationship between the natural log of income on the natural log of quantity, that's the income elasticity, how income changes affect demand. So that's the income elasticity. This one is much lower than 1 in absolute value, so this is inelastic, meaning that there's a positive effect of income on quantity demanded, but the response of demand is not very high. So when you get more income, you buy a little bit more, but not very much. The demand is much less responsive than income changes. And you got to interpret this as the effect of income on demand in percent terms. So if income goes up by 1%, that coefficient is the effect on demand, which means quantity demanded increases by 0.0400%. Okay, so on your midterm, you'll have a question very similar to this. You'll get a little piece of data. You have to run the regressions, and just make sure you interpret the right terms. And yeah, the questions on this one? Okay, so number 3 is on the budget line analysis, similar to the homework question we did for chapter 4. Okay, so let's do this one. I'm gonna just pour some more coffee in my cup. Give me 30 seconds. Okay, so here you'll get a little budget line analysis, and kind of similar to what we did for chapter 4 homework. So for this one, suppose you have a budget of 120, and to maximize utility, you decide to spend all of your income on whiskey and pancake mix. So there's two goods that you can spend your budget on. The price of whiskey is $40 per bottle, and the price of pancake mix is $10 per box. Okay, and this I just kind of wrote down the general equation to start with. And so remember that this is just the general equation for a budget line. The price of good X times X, that's the price of good Y times Y equals M, your income. So this is if you exhaust all of your budget, this is the general form. Okay, just pick one of the goods to be X and one of the goods to be Y. So I made X whiskey and Y pancakes, which means that the price of XTX is the price of whiskey, and the price of YPY is the price of pancakes. Okay, and this is I just put in the prices and the income to specify the equation. So the price of X, which is whiskey, is 40, so it's 40X, plus the price of Y, which is the price of pancakes, 10, equals our income. So our example here for our budget line is 40X plus 10Y equals 120. So I think it's nice just to write out your budget line with the prices and the income just to get you started with this. Okay, then part A is construct a table showing the alternative combinations of the two products that are available. Okay, and so you just have to specify the whole numbers of each. So don't worry about the decimal combinations, just what are the whole numbers of the combinations you can get. Okay, and so you're trying to have different combinations of 40 times X plus 10 times Y that give us our whole income of 120. Okay, and so I did this in Excel. You can look at if you want to do it in Excel, you can use mine as a template. You're welcome just to write it on a piece of paper if that's easier, whatever is easier for you. But my example is here on the practice midterm solutions on the Q3 tab. Okay, so I basically just wrote a formula. It's a simple formula, but it's just saying that 40 times, how much X we buy, plus 10 times how much Y we buy has to equal 120. And this will give us different combinations given the relative prices. Alright, so basically you can buy 3 bottles of whiskey, which will give you 120 and no pancake mix. Or you could buy 2 bottles of whiskey and 4 boxes of pancake mix, because whiskey is 4 times the price. You can buy 1 bottle of whiskey and 8 boxes of pancake mix, or if you bought only pancake mix, you could buy 12 total boxes of pancake mix. Alright, so all of those combinations of X and Y would give us would exhaust our income, and so you can just do a little simple chart like that showing the whole numbers, the whole values of the combinations. Don't worry about like 2.5, just pick the whole numbers. Okay, so I put that there. Here's here's the combinations of X, the number of whiskey, and the number of pancakes. All of these combinations add up to 120. And these are all the combinations for whole numbers. Okay, part B is plot the data in your table as a budget line and a graph. So just take the combinations and plot them to make a budget line where here pancakes will be on the y-axis and whiskey will be on the x-axis. Okay, so I did it in Excel. You're welcome to use Excel to do it if you like, or you can just, if you prefer to draw it in Word or just by hand, you can do that too. But if you do in Excel, you can just plot the points like I did here. And so if we spend all of our money on whiskey, we can buy 3 bottles. If we spend all of our money on pancakes, we can get 12. Okay, and then these are the combinations 03, 24, 18, and 012 that we can put on our budget line. Okay, so if you're going to use Excel or some other outside source, make sure you copy and take a screen cap or you paste your graph in there. So there's the graph, the budget line. Okay, so continuing on part B, what's the slope of the budget line? Okay, so you know that the slope is just given by the price ratio. So the slope of the budget line is always negative px over py. In our case, negative 40 divided by 10. So 40 over 10 is px over py. And that gives us a slope of negative 4. Okay, then the rest of part B is what's the opportunity cost of 1 more bottle of whiskey and of 1 more box of pancake mix. Okay, so the opportunity cost of whiskey is, you can see that every time you buy a bottle of whiskey, you give up 4 boxes of pancake mix. Okay, so plus 1 minus 4, plus 1 minus 4, so each time you gain this, you got to give up 4 pancakes. And then flip that around, you can see that every time you gain 4 boxes of pancake mix, you give up a bottle of whiskey. So for pancakes plus 4, you're going to give up one or the other. Okay, if you put that in terms of pancake mix, it's divided by 4. That means that 1 box of pancake mix is equivalent to giving up a fourth a bottle of whiskey. Okay, so here's the opportunity cost of each bid. 1 bottle of whiskey, you give up 4 boxes of pancake mix, and 1 box of pancake mix, you give up a quarter bottle of whiskey. So they should be, when you go back and forth, it should be the same thing as you express one in terms of the other. Okay, and there's my original budget line with the income of 120. All right, and then part C, as a result of the government stimulus payment, suppose your budget increased to $400, it will show the new budget line for part C with the extra boost in income. Okay, so I did this part in Excel I just made a new table. Okay, so the price ratio doesn't change, but we can buy a lot more of each of the goods. So we can buy these combinations now. So these are the total combinations of total numbers of items we can buy. You can buy anywhere from 0 to 10 total bottles of whiskey, anywhere in increments of 4, 0 to 40 boxes of pancake mix. Okay, so the budget line formula is the same, but the income went up from 120 to 400, which gives us more combinations, and basically the budget line just shifts out. All right, and these are all the combinations that give us that $400. Remember, the slope of the prices didn't change, so the slope is the same. Okay, so if you compare the two, you can see that this was 12 and this was 8. This was 3, and it shifted out to 40 and 10. So it just with the same slope, it shifted out, but these are the new intercepts, 40 and 10. And these are all the new combinations, which would give you these different combinations of pancake mix and whiskey with the increase in income. Okay, so if you're doing this in Excel, you make sure you put the graph in there. And yeah. All right, then for D, let's suppose that the price of a box of pancakes increased to $20. Let's draw the new budget line, and remember you're continuing on with part C, so your income is now 400, but the price of pancakes increased to $20. Okay, so in my graph I just made a note of what was changing. So the first one, our income was 120. The second one, our income was 400, and the third one, our income went up to 400, but the price of Y increased to 20. So we have $400 of income, but the price of Y is more expensive. Okay, so this is going to change the slope. Okay, so the original budget line equation was 40x plus 10y equals income. And so now it's 40x plus 20y because the price of y went up to 20. So these are all the combinations of 40 times x plus 20 times y that give us exactly $400. Alright, so see we can buy the same amount of, the whiskey column didn't change. That goes from 0 to 10, but the amount of pancakes we can buy now is half what we used to have. So this goes up in increments of 2 as opposed to increments of 4 because the price went up. So this is now, you can buy all whiskey and have 10. You can buy all pancakes and have 20, or these different combinations that will give you alternative combinations of both, all of which sum to $400. Okay, and so note the slope of this curve has changed because the price of X is now 20, not 40. And so instead of 4 over 1, it's 2 over 1, which means the slope is now negative 2. Okay, if you're doing this in Excel, you can just plot the points, and you can see that basically what happened is the y-axis intercept changed, it shifted in. So up here was 40, and down here it kind of shifts in or kicks into 20. But notice that the price of X didn't change, and so therefore the x-intercept is going to be the same from the previous one. And so this shifts down to 20. Okay, so we kind of represented a income change and a price change. The income change shifts the curve up or down, and the price change shifts or kinks the budget line depending if the price goes up or down. Okay, so there's that final budget line with an income of $400 and the price of 20, and so that shows you can see kind of the evolution of changes. There's the original combination with 120, then the income goes up, our budget line shifts out. You now buy a lot more of both at the same price ratio. But when the price of Y goes up, we can buy less of it, so the budget line shifts in, and the y-intercept becomes 20 instead of 40. Okay, so for this one, again, you're welcome to use my Excel work as a template or example. If you want to do it in Excel, you don't have to do it in Excel. It might be easier for you to do it on graphing paper or Microsoft Word, just using the charts. But so however you want to do it, make sure you answer all the questions, put the charts in for that one. So I think that's for number 3. Any questions on this one? The budget line analysis, similar to chapter 4 homework. Everybody good on this one? Okay, seems like we're good right now. Okay, so we got another one to do, but so I'm done with the Excel portion. So this is posted on Blackboard if you want to see it. But I use Excel. You have to use it for the regression, and then if you want to use it for question 3, you can do that as well. But you can also do the graphs by hand if that is easier for you. Okay, number 4. Here we have, let's suppose we're going to have 2 questions where you choose the appropriate level of labor to or to minimize your cost. Alright, so we did one similar to this in chapter 5 last week. And there was one on the homework, I think, too. Okay, so let's suppose a firm produces output that can be sold at a price of $10. Production function is this, which is a Cobb-Douglas, K to the 1/2, L to the 1/2. And part A is if capital is fixed at 1 in the short run. How much labor should the firm employ to maximize profits if the wage rate is $15? Alright, so your profit maximizing input usage, even though that your condition holds, is you want to find the output in which the value marginal product of labor equals the wage rate. So this is the condition you need to satisfy. Alright, so the first thing you want to do is plug in the 1 or whatever value your capital is. So in this case, so capital is going to be fixed. In this case, it's fixed at 1. So plug in a 1 for K. So Q is the function of capital and labor when capital is 1. Put the 1 in there. And that just simplifies 1 to the base anything is just 1. So F to the 1L is L to the 1/2. Okay, now we can get the marginal product of labor, which is the derivative of the production function with respect to labor. Okay, so we're differentiating L to the 1/2 with respect to labor. So just bring down the exponent and then subtract 1 from the exponent. So it's 1/2 L, and then 1/2 minus 1 is minus 1/2. So the derivative, or the marginal product of labor, is 1/2 L to the minus 1/2. Okay, so we have the marginal product of labor. Let's get the value marginal product of labor, which is the price times the MPL. Okay, so the price is given at 10. And let's multiply that by the MPL we just calculated, which is 1/2 L to the minus 1/2. So it's 10 times 1/2 L to the minus 1/2, and 10 times a half, or a half of 10, is just 5. So the value marginal product of labor is equal to 5L to the minus 1/2. Alright, so final step is to set the VMPL equal to the wage rate, and that's the best we can do with our input choice. Alright, there's our profit maximizing input usage, where we want to find VMPL equals W. So VMPL for us, we got that, is 5L to the negative 1/2. And set that equal to the wage rate of 15, which was given. And then we can just solve for L. There's nothing else to do to solve for L. Divide by 5, we get L to negative 1/2 equals 3. And if you raise both sides to the minus 2, that gives you L equals 3 to the minus 2. And the final answer comes out to L star equals 1/9. So the final number came out a little weird, but I'll try to make it. I think I made the number on the midterm exam more. It's not a fraction, but this one came out to L star equals 1/9. Alright, so that's L star, a very small number, but that's just how this one came out. Okay, so you'll get one of the top Douglas and one of a linear form. Okay, so instead, suppose the second part of this question is, let's suppose a firm produces output sold at the price of $1. The production function is this form, where it's 1K plus 10L squared. So it's a variation of the linear. And so do the same analyses, just use the different production function and the different price and wage rate. So if capital is fixed at 2 units this time, in the short run, how much labor should the firm employ to maximize profits if the wage rate is 40? All right, so you want to satisfy the same condition and then solve for L. Okay, so first plug in what capital is. So capital is fixed at 2. So after the 2L equals, just put in a 2 there. All right, so 1 times 2 is capital is 2 plus 10L squared, and that simplifies to Q 2L equals 2 plus 10L squared. All right, so that's your production function with capital fixed at 2. All right, so now you want the MPO, which is to differentiate that production function with respect to labor. So differentiate that with respect to labor. And so the 2 part doesn't affect labor, so that's 0. But the L part, so bring the exponent down and then subtract 1. So it's basically 2 times 10 times L to the 2 minus 1, so it's 20 times L to the 1, which is of L. So if you differentiate this with respect to labor, you just get 20L, right? So 2 times 10 is 20, and then 2 minus 1 is just 1. So the full MPO, or derivative of that, is 20L. Okay? You see that? All right, and then you want to find the value margin of product, which is defined as the price times the MPL, right? And so the value margin product is the price, which is 1, it's given at 1, times the MPL, which we just calculated, which is 20L. Okay, so 1 times 20L is just 20L. Okay, so our VMPL is 20L. Okay, so the same step, to maximize profit, we want to set the VMPL equal to the wage rate, right? That's the whole goal. And so VMPL is 20L, and the wage rate was given at $40. So $40. So we get 20L equals 40, and from this point, we're just solving for L, and all we have to do is divide by 20. So 40 divided by 20 is L, is 2. So L star is 2. Okay, so for this one, follow the same recipe to get, you want to find the VMPL and set it equal to the wage rate and solve for L. And you'll get some variation of the Cobb-Douglas for the first part, and then some variation of a linear function for the second part, and capital is going to be fixed at some number in the short run. Okay, so questions on this one, number 4, on the profit maximizing labor choices? Okay, so can you show the step between the formula for MPL and the answer? Yeah, okay. This part right here? Okay, so this is basically what you do. You're starting with the production function is 2 plus 10L squared, right? And the MPL, so I took the full derivative of that. All right, so if you bring the 2 down, it's 10 times 2, and it's then raised to you subtract 1 from the exponent, so it's 2 minus 1. If you simplify that, it's just 10 times 2, which is 20, and then L to the 1, because 2 minus 1 is 1, and that simplifies more to 20L. Okay? You see that? Okay. You're welcome. All right. So any more questions on this problem or any of these other types of problems? Okay. So all right. So looks like everybody turned in all the homework assignments so far. So I will post the homework solutions if you want to see those to compare your answers for the for studying for the exam. So let me write that here. All right, so I'll post my homework solutions for chapters 1 through 5 later tonight, and you guys can look at those. And I haven't tallied up your homework grades yet, but I'll get those when I do the midterm grades. Okay, so let me go ahead and post the midterm to Blackboard. So just give me a minute. Okay, so if you look at Blackboard and you go to the midterm spring 2020 section, all right, so there's all the midterm practice stuff we just did. If you want to look at that, and then your midterm is right here, midterm spring 2020. Okay, so it should be similar to what you just saw. There's some instructions where it says, this is just like the syllabus. You want to submit this by email by week 6, Friday, May 1st, which is next Friday. And there's my email address, which you already have. And it says, if you can send me a PDF or a Word document, that's preferred. And so if you can't, let me know, but either of those is preferred because it's easier to grade than a bunch of pictures. But if you can't do a PDF or a Word document, let me know and we can work something out. Okay, and then you got your questions here. Number 1, on net present value. Number 2 is on the elasticity regression analysis, and it says use this file for your midterm, which I just posted on Blackboard. That's right here. Okay, so you get some natural log data that you got to use for that problem. Okay. All right, and then you got one on the budget line analysis, and you got one on the profit maximizing usage. So some variations of what we did just now as practice, what you've done. But there's your midterm, which is due next Friday by email, like it says in the instructions. So everybody's done all the homework assignments except the elasticity one. Okay, but next, so and you probably already, some of you have probably already done the elasticity one, but make sure next week you got to turn in both of these things for week 6, Friday, May 1st. So turn in the elasticity homework that I gave you guys like a month ago. Okay, so that one you posted here. Just post just like a normal homework. Okay, and then the midterm answer sheet you're going to email to me, just to my email address. So those are the two things you got to submit in a week. You should have plenty of time, but just to make sure you got those two things to do. So by next week, submit your elasticity homework by discussion forum on Blackboard and submit your midterm answer sheet via email. Okay, and then we'll start kind of the second portion of the class next Friday, and we'll start with chapter 8 next Friday. Okay, so any questions on what you have to do for your midterm or the elasticity homework? And if both of those are due in a week. Okay, so we'll wrap it up here in a minute, but just as a reminder, under chapter 3, all the stuff you need for the elasticity homework is there. And then under midterm spring 2020, there's your midterm with the data set that you need for that. All right, and so other than that, I will post the homework solutions, and I'll let you know where those are. And I'll post today's WebEx recording if you guys want to listen to that in the same spot. So anything else before I let you guys work on the midterm and the homework? Okay, well, looks like everyone's here, all 30 students, and everyone turned in their homework on time, which is great, so thank you. And so we'll wrap up this meeting. Assuming there's no more questions, you're welcome to log off. And make sure you get your midterm by next Friday by email, your elasticity homework in the Blackboard spot. And then that's it for tonight. Unless you have any additional questions, you are free to go. And have a good weekend. And thanks for joining and getting on time.